We're going to be solving right-angle triangle problems. Okay. There are essentially four major formulas you guys need to know. Three of them are the primary trig ratios. So you need to know your sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Though we haven't spoken about it, you guys know from previous years Pythagoras Theorem, which comes in very handy with right-angle triangles, especially if you're looking for a side and already have the measurements of two other sides. You'll also have to know your scale factors for similar triangles, but that should pretty much get you through everything. So we scroll down to this question here. The very first question asks, how tall is this building? So we have our character here, Callum. He's standing at his balcony. He's across from a building, or there's a building across the road from him. His balcony, I guess I should have put that over here, is 20 meters above the ground. Okay. Callum decided to measure the angle of depression. What would the angle of depression be from where he is? Which of these two angles is considered the angle of depression? 42. The one heading downwards. So he discovered that the angle of depression to the bottom of the other building is 42 degrees. And he also discovered that the angle of elevation, which is 36, to the top of the other building is 36 degrees. He wants to figure out how tall the other building is. Okay. So what he's going to do is he's going to make right-angle triangles out of this. Now, because this balcony is 20 meters up, he knows that directly across from him is 20 meters above the ground. In other words, from here to the bottom of the building is 20 meters. Since we have two right-angle triangles, one of them we only have an angle, we don't have any side lengths to help us solve this information, but they do have a similar side, or a corresponding side. This side happens to be the one that runs down the middle. You could call it the height of both of them, or the base of both of them. What we're going to do is we're going to solve that for that side. We'll call it x. And when we solve for that x, we'll have pieces of both triangles. Now, in order to solve for x, we're going to have to use one of our primary trig ratios. If we have the angle 42 degrees, 20 meters is what side of the triangle in reference to that? It's opposite. Okay? Which means side x is what? Adjacent. If we're dealing with opposite and adjacent, which of the ratios do we deal with? Tan, that's good. So tan theta is equal to opposite over adjacent, which in this case happens to be tan 42 is equal to opposite, which is 20, over adjacent, which is x. Okay? So our goal here is to isolate that x. I'm going to bring x to the other side because it is on the bottom. We can't just isolate it if it's on the bottom of a fraction. When I bring x to the other side, it becomes multiplied by. So we have x multiplied by tan 42 is equal to 20. But we still have an isolated x. Tan 42 is still on the other side, and it's multiplied by. So in order to move tan 42 over, what do we have to do? We're going to have to divide 20 by tan 42. Excellent. So that will leave x on this side, and we'll have 20 divided by tan 42. This is where we take out our calculators and try to figure this out. So we have 20 divided by bracket 42 tan end bracket equals 22.21. 22.21. Okay, we'll leave it at 22.2. So the distance to the other building happens to be 22.2 meters. That actually answers our second question, right? So in the process of solving the first one, we've already answered the second question of how far apart are the two buildings. We discover that Callum is 22.2 meters apart from the building across the road. But we still need to figure out the height of that building across the road. Since we now have a similar side, we know that the distance is 22.2. Let's recreate the other right angle triangle at the bottom. So the other I'm going to move that. The other right angle triangle looks something like this. It had an angle of elevation of what? Anyone remember? 36. Okay. The angle of elevation was 36 degrees. And how long was this base? We just figured it out. Good. So 22.2 meters. So Callum's balcony was roughly this high. How much higher up is the top of the other building? In other words, we're looking for this, and we're going to call it y. So in other words, that would be the y part of this. Okay? So again, we're using angle 36. Remember, we're never using the 90-degree angle to use the primary trig ratios. We always have to use one of the other two angles. In this one, side 22.2 is considered what in reference to that angle? Adjacent, good. And y would be, so what ratio are we using again? We're using tan again. Tan 36 is equal to opposite, in this case, which is y, over adjacent, which is 22.2. This one's a little easier to solve. We only have to isolate y, and y is already on the top of the fraction. So when we move our 22.2 to the other side, it becomes multiplied by tan 36. From here, we can just go about solving. We don't have to do any more moving around because we've already isolated our unknown variable y. So we take out our calculator, 36 tangent times 22.2 equals 16.1, let's say. 16.1 meters. So, from Callum's balcony to the top of the other building is 16.1 meters. How tall is the other building? Yes, we're going to have to add these two, okay? It doesn't mean that the building is 16.1 meters, but we have to add how high up Callum's balcony is, and then how high from his balcony to the top of the other side. Connor? Great. So the other building is 36.1 meters tall in this case. So how tall is the other building? We got it, 36.1. How far apart are they? We had to solve that in the process of figuring out the height of the building. So we don't actually have to put in any work for that one. We already have an answer of 22.2 meters apart. And finally, is he closer to the top or the bottom of the other building? So in other words, we're going to be measuring the distance from where he is to the top and the distance to the bottom. What sides of the triangles are we going to be looking for then? Hypotenuse, good. So we have to solve for both the hypotenuse of each of the other triangles. So we're going to recreate both of them down here at the bottom. Flip these around. We'll pause this. Okay, so we recreated both of the other triangles down here. Our goal is to find out the hypotenuse of both of these triangles. I'm going to call them A and B. Okay? We're going to call them A and B. There are several ways we can go about solving this. Okay? Let's think of these in terms of our ratios to start. And we're going to list a whole bunch of them, and we'll solve using one of them. I have this angle here, 36 degrees. And I need to find the hypotenuse of this triangle. Well, I have the opposite side. So which ratio deals with opposite and hypotenuse? Sin, right? So we have sine 36 is equal to opposite, which in this case is 16.1 over A. Or I also have the adjacent side, which is 22.2, which means I could have used cos 36, adjacent being 22.2, over hypotenuse, which is A. Both of those will help solve for A in this triangle here. Okay. We cannot use tangent for that one because we're looking for a hypotenuse. But there's a third way we could solve this. Anyone know? Pythagoras Theorem, right? We have two sides of the triangle. So we could use our A squared plus B squared equals C squared to solve. So we'll go through that. We'll call it A22. Well, I guess because we have an A here, we'll rename this. This becomes our C in this question because we're looking for the hypotenuse. So our A maybe is known as 16.1 squared plus 22.2 squared is equal to C squared. So we'll use our calculator and try to do this in one shot. 16.1 squared plus 22.2 squared equals 752. We're going to round it, okay? Approximately 752. But that doesn't make sense. That distance can't be 752 meters. What do we still have to do? Square. We need to square root both sides, right? We square root both sides. C is approximately, we find the square root of this version. Where's my square root? Well, I'll pause and find it. Okay, we found it. Square root of 752 is 27 What was it? 27 point what? 4. So approximately 27.4. So that's how far away he is from the top of the one building. We got to do the same thing on the bottom. So we have 42. We could set up sine. We could set up cos. But we might as well just go through our Pythagoreans again. In this case, we have 20 squared plus 22 squared is equal to, and we're going to call this one b squared. We're looking for the b squared in this case. So same idea. 20 squared plus 22.2 squared equals 892.84. 892.84. Is that right? 892.84. Great. And we need to find the square root of that, which is 29.8. So b equals 29.8. Is he closer to the top or the bottom of the other building? He's much closer to the top, right? He's 29.8 meters away from the bottom, but only 27.4 meters away from the top of the building. So many questions we solved using all three of those ratios. Oops, wrong one. Bye.